In this movie, we're going to enter the world of rotation in video games. In particular, we're going to look at how we can use script to rotate objects. Now, this may, at first sight or at first sounding, seem a very trivial matter, but it is not trivial in the least, because there are many different problems and issues that arise when rotating objects. So, for example, I have this scene in front of me here, and I may want to rotate this object. Now, to do that, we know using the standard viewport controls inside the Unity editor that we have to rely on the rotate tool, or we can type in the values into the rotation field here in the transform component. Now, some of the questions that arise when rotating objects is 1. How can we rotate an object from where it is right now to face a new direction? How can we rotate an object to face a particular object? How can we rotate an object smoothly over time? And in some cases, we may want to say, how can I rotate one object around another object so that it orbits another object? These are all issues that we face when addressing rotation, and we're going to have a look at all of these questions throughout this part of the course. Now, before I go any further, I want to introduce you to the way that rotation works inside Unity. Unity represents rotations or orientations by using a structure, a mathematical structure known as a quaternion. Now, quaternions are not simply just angles. They are made up of a combination of angles. So let's take a look at what's going on here in terms of this capsule in the scene viewport. Right now, this capsule has been positioned in the scene. It's not actually at the origin, its position is offset. But in terms of its rotation, it is not rotated at all. We can confirm this because for the rotation, the X, Y, and the Z fields are all 0, meaning that it hasn't rotated at all. Now notice that the rotation here is defined in terms of its orientation across 3 separate axes, or 3 pivot points of rotation. So we have the rotation of the object around the x-axis, and if I increase this, you will see that this object is now pitching. So it's moving up and down, and it's rotating around the red axis pointing out of the side here. So it's using that as the center of rotation because that is the x-axis, and it's rotating around that center. I'm going to put that back to 0. We can also rotate around the y-axis, and this is the axis that is pointing upwards. So it was going to use this as the center of rotation, and this kind of rotation is known as yaw, Y-A-W, beg your pardon, yaw. So if I click and drag that slider, you can see we're now rotating around the y-axis. I'm going to undo that by putting that back to 0. And finally, we have the z-axis, which is known as roll. So again, we have the z-axis or the forward vector pointing straight ahead here. And by dragging in that direction, we can see that we are now rotating around that axis as the pivot point. Now, using any combination of these 3 different types of rotations, it is possible to orient an object absolutely anywhere within 3D space. Using these 3 combinations of rotations, we can orient an object absolutely anywhere. And ultimately, these 3 axes together and the amount of rotation we apply to each is what makes up entirely a quaternion. A quaternion is made up of the amount of turn on each of these 3 axes. Now, of course, underneath or internally, there's a lot of mathematics going on with quaternion that Unity handles for us. We don't need to worry too much about the internal mathematics that happens. We simply need to know how to use the quaternion class that Unity provides. But just to show you that there's more that meets the eye in terms of the mathematics of what's going on inside Unity, we can actually see that at work. If I just bring in the window here slightly, and I move up to the top right hand side of the object inspector and click on this drop down icon here, and I change the presentation of the inspector from normal mode to debug mode, we can see here in the object inspector under the transform field that pretty much the position and the scale of the object remain as they were presented before. we get the X, Y, and Z transformation fields for position and scale. And these look very similar to the position and scale values, how they were presented in the normal mode. But notice that rotation is presented differently. And if I expand the local rotation field, you can see that previously, whereas we had X, Y, and Z fields, we still get those. But there is an additional W field. And that is because a quaternion mathematically is made up of primarily 4 numbers, and these are X, Y, Z, and W. The W field is handled and managed internally by Unity, and we don't need to worry about it. But I want to show you that it is there. So I'm going to switch the inspector back from debug mode back to normal mode, and the rotation is now presented as it was before, considering the amount of turn around each axis. So with that basic explanation of quaternions in place, we can now move forwards to actually rotate objects using quaternions.